Hello everyone, let's do miscellaneous properties under sets. Under this, we will be approving few properties. First, let A, B and C be the subsets of the universal set U. Then A union B intersection C equals A union B intersection A union C. A intersection B union C equals A intersection B union A intersection C. A union A complement is universal set. A intersection A complement is phi, and A complement of complement is A. So let's begin with the first proof. A union B intersection C equals X such that X belongs to A or X belongs to B intersection C, X such that X belongs to A or X belongs to B, or and X such that X belongs to A or X belongs to C. Now, X such that X belongs to A union B and X belongs to A union C implies A union B intersection A union C. This is what we wanted to prove. Now, proof of second. A intersection B union C. X such that X belongs to A and X belongs to B union C. X such that X belongs to A and X belongs to B or X belongs to C. X such that X belongs to A and X belongs to B. Let's open the bracket. Or X belongs to A and X belongs to C. Now next step, X such that X belongs to A intersection B or X belongs to A intersection C. Implies A intersection B union A intersection C. This is what we wanted to prove. Okay, proof of second or first. A union A complement. X such that X belongs to A or, because of union we write or in the middle, X belongs to A complement. X such that X belongs to U, which gives U. So which we wanted to prove. Proof of second. A intersection A complement equals phi. X such that X belongs to A and X belongs to A complement. X such that X belongs to A and X does not belongs to A. X such that X belongs to phi, which is equal with phi. Good. Proof of third. A complement equals A. X such that X does not belongs to A complement. If X does not belongs to A complement, that means X belongs to A, which is equal with A, which we wanted to prove. Let's do De Morgan's law. De Morgan's law. And we need to remember a very short trick. De Morgan's law divides complement into two different pieces. If we have union ko complement, then while breaking it, it gives the complement in intersection. A union B ko complement like De Morgan's law ले चाहिँ break गर्दा A complement intersection B complement मा गर्छ र intersection को complement छ भने चाहिँ while breaking it A complement union B complement. So easy to remember. एउटा के ट्रिक याद गर्न सकिन्छ भने A union B complement छ भने यसले ब्रेक गर्दा चाहिँ A complement intersection B complement मा ब्रेक गर्छ र intersection को complement छ भने ब्रेक गर्दा A complement union B complement मा. And one more trick, if we have does not belongs to sign with A union B, does not belongs to sign. When we have union sign with that, we used to write or. But if we have does not belongs to A, X, A union B ma पर्दैन. That means X does not belongs to A. In place of union, we write here and. If we have union with does not belongs to sign, हामीले यहाँ and लेख्ने and X does not belongs to B. Similarly, X does not belongs to A intersection B छ भने generally intersection हुँदा we always write and, but पर्दैन भन्दा X A र B मा A र B को common member होइन. That means X does not belongs to A or X does not belongs to B. This is a very small trick. Now, while proving this, proof of first. A union B complement equals A complement intersection B complement. X such that X does not belongs to A union B. X A union B ma पर्दैन. That means X such that X does not belongs to A and X does not belongs to B. X such that X does not this implies X does not belongs to A means X such that X belongs to A complement and X does not belongs to B, that means X belongs to B complement. A मा पर्दैन भने A complement मा पर्छ, B मा पर्दैन भने त्यो B मा चाहिँ पर्ने भयो. So it gives A complement intersection B complement, which we wanted to prove. Let's do the proof of second. A intersection B complement. X such that X belongs to A intersection B complement. That means X such that X does not belongs to A intersection B. Implies X such that X belongs to X does not belongs to A or X does not belongs to B. X does not belongs to A. That means X belongs to A complement. X does not belongs to B. B मा पर्दैन भने B मा X belongs to B complement. B complement मा त पक्का पर्छ. So X such that X belongs to A complement means A complement or means union X belongs to B complement. So A complement union B complement, which we wanted to prove. Proof of first. A minus B intersection C. X such that X belongs to A and X does not belongs to B intersection C. A minus B intersection C means beside B intersection C, pure A. So X, if X belongs to A, X does not belongs to B intersection C. X says that X belongs to A, and when we have does not belongs to sign with intersections, what we write? Or. So X does not belongs to B, or X does not belongs to C. This means X doesn't lie in B intersection C. X B intersection C ma parदैन, that means X does not belongs to B or X does not belongs to C. Okay, now X says that X belongs to A and X does not belongs to B. Similarly, X belongs to A and X does not belongs to B, or X belongs to A and X does not belongs to C. This means X A ma पर्छ, B ma पर्दैन, A ma पर्छ, C ma पर्दैन. X belongs to, that means X says that X belongs to A minus B. A ma पर्ने तर B ma नपर्ने means pure A minus B, or X belongs to A minus C. X belongs to A minus B or X belongs to A minus C. That means A minus B or means union A minus C. Proved. Proof of first. A minus B intersection C. X says that X belongs to A, but X does not belongs to B intersection C. X A ma पर्छ तर B intersection C ma पर्दैन. X says that X belongs to A, and when we have does not belongs to sign with intersection, while opening it we write or. X does not belongs to B or X does not belongs to C. Implies X says that X belongs to A and X does not belongs to B, and as X does not belongs to B, or it is or over here, or X belongs to A and X does not belongs to C. X belongs to A but X does not belongs to C. Implies X says that X belongs to A but not B. That means X belongs to A minus B. A ma पर्ने तर B ma नपर्ने. Or X belongs to A minus C. X belongs to A but not in C, which gives X belongs to A minus B or X belongs to A minus C. That means X says that X belongs to A minus B union X belongs to A minus B or X belongs to A minus C. That means X belongs to A minus B union A minus C, which we wanted to prove. Now proof of second. In second we have A minus B union C. It means X says that X belongs to A and X does not belongs to B union C. Because A difference B union C means beside B union C only A. X says that X belongs to A, and now remember the trick which I told you before. X does not belongs to B union C. When we have does not belongs to sign with union, while opening we write and. That means X does not belongs to B union C means X B ma पनि पर्दैन, X C ma पनि पर्दैन. So X does not belongs to B and x does not belongs to C. So don't get confused. Though here is union, we write and over here because here we have does not belongs to sign. When we have does not belongs to sign, x does not belongs to B union C means x is not the member of B, neither the member of B nor the member of C. That's why x does not belongs to B and x does not belongs to C. Now x says that x belongs to A and x belongs to A and x does not belongs to B. Similarly, and x belongs to A and x does not belongs to C. X says that x belongs to A, x does not belongs to B, x belongs to A, x does not belongs to C. This implies x says that x belongs to A, x does not belongs to B. That means x belongs to A minus B and x A ma parcha but not in C. That means x belongs to A minus C, which gives A minus B. In place of and we write intersection and A minus C, which is proved. Okay, proof of third. A intersection B minus C. This means x says that x belongs to A and x belongs to B minus C because here is intersection sign. X says that x belongs to A and x belongs to B minus C means x is the member of B but not of C. X belongs to B and x does not belongs to C. X belongs to B and x does not belongs to C. Implies x says that x belongs to A and x belongs to B. X belongs to A and x belongs to B and x belongs to A but and x does not belongs to C. Implies x belongs to A and x belongs to B. That means x says that x belongs to A ma pani parne, B ma pani parne means A intersection B and x belongs to A and x does not belongs to C. That means x belongs to A, x belongs to A and x does not belongs to C. When we see A ma parne, C ma na parne, A minus C. Implies x says that x belongs to A and x belongs to B means x belongs to both. That means A intersection B and x belongs to A but not C. That means x does not belongs to A intersection C, which implies A intersection B, x belongs to A intersection B but x does not belongs to A intersection C means A intersection B minus A intersection C, which we wanted to prove. Let's do few questions under this. First one, prove that A intersection B is improper subset of B. A intersection B is improper subset of A. Let's do the proof of first. A intersection B. A intersection B means x says that x belongs to A and x belongs to B. That means x says that x belongs to B, which is x belongs to B means B. Therefore, A intersection B is subset of B. Now, proof of second. Proof of B. A minus B. X says that x belongs to A and x does not belongs to B. X says that x belongs to A which means A only. Therefore, what we can say, A difference B is improper subset of A. Proved. Now the question number 2, if A intersection B equals phi, then prove that A is subset of B complement, B intersection A complement is equal with B. Let's begin with the first proof. A is subset of B complement. It means let X belongs to A, X does not belongs to B. That means X belongs to B complement. If X belongs to B complement and X belongs to A, that means A is subset of B complement. Proof of second, B number, B intersection A complement. X says that X belongs to B and X belongs to A complement. X B मा पनि पर्छ, A complement मा पनि पर्छ. X says that X belongs to B and X does not belongs to A. B मा पर्छ तर A मा पर्दैन. That means X says that X belongs to B only, which is equal with B, which we wanted to prove. Proof of 3. If A is subset of B, prove that B complement is subset of A complement. Proof of this, X let X belongs to B complement, X does not belongs to B. This implies X does not belongs to A because because A is subset of B. So X does not belongs to A means X belongs to A complement. Therefore, B complement is the subset of A complement. Now in B number, A union B equals B. To prove this, X says that X belongs to A or X belongs to B. X says that X belongs to B. As A is subset of B, we can say X belongs to B, which is equal with B. Therefore, A union B is equal with B. Prove that B minus A equals B intersection A complement. Proof of this. X says that X belongs to B and X does not belongs to A. Guys, X says that X belongs to B and X does not belongs to A means X belongs to A. Implies X says that X belongs to B intersection A complement. X does not belongs to A means X belongs to A complement. A मा पर्दैन भने complement मा पर्छ. B intersection A complement implies B intersection A complement. Proved. Next proof, A minus B complement equals A intersection B. So let's start with the left side. A minus B complement means X says that X belongs to A and X does not belongs to B complement. X says that X belongs to A and X does not belongs to B complement means X belongs to B. X belongs to B. That means X says that X belongs to A and X belongs to B means X belongs to A intersection B, which is A intersection B. Now next example, let's prove that A minus B equals B complement minus A complement. So proof of this, A minus B. X says that X belongs to A but X does not belongs to B. X belongs to A, that means X says that X does not belongs to A complement and X belongs to B complement. X says that X does not belongs to A complement and x belongs to B complement. X does not belongs to A complement, x belongs to B complement. That means if we write this term in front, x says that x belongs to B complement and x belongs to A complement. X says that x belongs to B complement मा पर्छ तर A complement मा पर्दैन. That means x says that x belongs to B complement minus A complement. A complement मा चाहिँ पर्दैन. Now we just have arranged this part. X does not belongs to A complement. We have written at the back, and x belongs to B complement in front. X says that x belongs to B complement मा पर्ने तर A मा नपर्ने. That means x belongs to B complement minus A complement implies B complement minus A complement. Proved. Proof of, we have question number 6. If A, B and C are the subsets of a universal set U, now we need to prove that A union B complement equals A complement intersection B complement. A intersection B complement equals A complement union B complement. A minus B union C equals A minus B intersection A minus C equals A minus B minus C. A minus B intersection C equals A minus B union A minus C. Let's begin with the first proof. A union B complement. A union B complement. X says that x does not belongs to A union B. As I have already discussed before, if we have union sign with does not belongs to sign, in place of or while opening we write and. So x says that x does not belongs to A and x does not belongs to B, which gives x does not belongs to A and x does not belongs to B. That means if x does not belongs to A, x says that x belongs to A complement, and if x does not belongs to B, that means x belongs to B complement. B complement. That means A complement in and means intersection B complement, which is proved. Now, proof of second B number. What we have? A intersection B complement. This means x says that x does not belongs to A intersection B. That means x says that x does not belongs to A. So when we have does not belongs to sign in intersection, we write or while opening it, or x does not belongs to B. This implies x does not belongs to A. That means x belongs to A complement, or x does not belongs to B. That means x belongs to B complement. Now here x belongs to A complement or x belongs to B complement, or means union. So x belongs to A complement union B complement, which is equal with A complement union B complement. Proved. Now proof of C. A minus B union C. X says that x belongs to A and x does not belongs to B union C. X says that x belongs to A and x does not belongs to B union C. When we have does not belongs to sign with union, while opening bracket, x does not belongs to B and x does not belongs to C. This means if x does not belongs to B union C, that means it is not in B, neither in B nor in C. X says that x belongs to A and x does not belongs to B, and x belongs to A and x does not belongs to C. gives x such that x belongs to A but not in B. That means x belongs to A minus B, and x belongs to A but x does not belongs to C. That means x belongs to A minus C. So now what we can write over here is x belongs to A minus B. That means A minus B, and means intersection x belongs to A minus C. That means A minus C. So A minus B intersection A minus C. Also A minus B union C equals x such that x belongs to A and x does not belongs to B union C. X such that x belongs to A and x does not belongs to B and x does not belongs to C. Implies x such that x belongs to A and x does not belongs to B. That means x belongs to A minus B and x does not belongs to C. It means x A minus B मा पर्छ तर C मा पर्दैन. That means x belongs to A minus B minus C, which is A minus B minus C. Proved. Now let's do the proof of D number. A minus B intersection C. X such that x belongs to A and x does not belongs to B intersection C. X such that x belongs to A and x does not belongs to B intersection C means, and x does not belongs to B, x does not belongs to B, or x does not belongs to C. B intersection C मा पर्दैन. We have does not belongs to with intersection sign, so we have written or. Now x says that x belongs to A and x does not belongs to B, or x belongs to A and x does not belongs to C. X belongs to A and x does not belongs to C. Gives x such that x belongs to A but not in B. That means x belongs to A minus B, or x belongs to A but not in C means A minus C. So here x belongs to A minus B or x belongs to A minus C. This means A minus B or means union A minus C, which we wanted to prove. Hence proved. Let's do real number system. In real number system, under real number system we have different types of numbers like natural numbers, whole numbers, integers, rational numbers, irrational number. The collection of all the different types of numbers are under real numbers. So let's discuss about natural numbers. Natural numbers, those numbers which starts with 1. All the counting numbers starting with 1 are called natural numbers. And then after whole numbers, natural numbers including 0 are whole numbers. Like natural number, it starts from 1, 1, 2, 3, 4, 5, 6, 7 and so on. Whole numbers 0, 1, 2, 3, 4, 5, 6, 7, 8. So that means natural number including 0 whole numbers. Now integers. In natural number and whole numbers we do not have any negative numbers, but in integers, natural numbers, whole numbers including negative numbers. In our number lines we have 0 in the middle. All the counting numbers starting with 1, these are natural number, including 0 whole numbers, including negative numbers as well. those numbers are integers. Integers means natural numbers including negative numbers as well. Now, after integers we have rational number. Rational number. Rational number means a number which is in the form of p by q, which is in the form of p by q when q is not equal with 0. Those type of numbers are called rational numbers. Why I am saying q is not equal with 0? If we have 0 in denominator, the value will be undefined. That's why we cannot keep 0 in denominator. But when q is not equal with 0, all the numbers which are in the p by q form are rational numbers. If we calculate them, their value can come in negative, but those negative numbers should be either terminating or reoccurring. For example, we have 100 by 3. If we divide, it will be 3 times 9, 3 times 9, 33.33333 reoccurring. So these numbers are rational numbers. It is in the p by q form and it is reoccurring decimal numbers. Either reoccurring or terminating. Both the types of numbers, if they are in the form of p by q, those numbers are rational numbers. Now let's talk about irrational number. Irrational numbers. Numbers which are in the p by q form, and if we calculate their value when q is not equal with 0, if we calculate their value, if their value comes in non-terminating decimal numbers, those numbers are called irrational numbers. To remember it in an easy way, what we can do, let's suppose these are the sets of natural numbers. Natural numbers including 0 are whole numbers, and whole numbers including negative, including whole numbers. If we are negative numbers as well, then those numbers are under integers. And here is rational numbers. In rational number, natural number, whole number, integer, everything lies under rational number. But irrational number is little different, because all the irrational number are not natural, whole, integers or rational number, but all these numbers are under one set, big universal set, and this set is called the real number system. So all the different types of numbers are under real number system. Real number system ले यो सबै number system हरुलाई चाहिँ लिन्छ. So सबै number system हरुको collection is only the real number. The whole real number systems are divided into two different categories: field axioms and order axioms. Under field axioms, we have divided into two different categories like addition and multiplication. Under addition, we have closure. Okay, field axiom. The whole real number systems are divided into two categories: field axiom and order axiom. Under field axiom, we have divided into two different categories like addition and multiplication. Both the categories we can divide into different parts like closure, commutative, associative, additive, identity, additive, inverse. Let's field axiom, addition and multiplication. Now first one is closure property. Closure property. Closure property means closed under certain operations like addition, subtraction and multiplication. Here we discuss about addition, subtraction and multiplication, but not division, because this property does not exist when we divide. Because if we have something 0 in denominator, the answer will be undefined. That's why it doesn't include division sign, only plus, minus and multiplication, closed under certain operations. In closure property, if A and B belongs to real number system, then A plus B, if we add those numbers, that is also belongs to real number system. So now, number next, associative. Not associative. Now, commutative property. Commutative property means if A and B belongs to real numbers, if we add A plus B, if we add A plus B, the answer will be equal with B plus A. So if A, B real number हो भने A र B लाई जोड्दा जे आन्सर आउँछ त्यसको आन्सर चाहिँ B र A लाई जोड्दा आउने आन्सरसँग पनि सेम हुनुपर्छ. This is what commutative property says. Number 3, associative. In associative property means if A, B belongs to real number, A plus B plus C must be equal with A plus B plus C. यसले के भन्छ भने कुनै पनि A, B, C, if A, B and C be real numbers, A, B, C belongs to real numbers, यदि A, B, C तीनवटा नम्बर रियल नम्बर भित्र पर्छ भने कुनै फर्स्ट एउटालाई जोडेर बाँकीको दुईटाको समसँग जोड्दा र फर्स्ट दुईटा जोडेर बाँकीको तेस्रो समसँग जोड्दा आउने आन्सर चाहिँ सेम हुन्छ भनेर एसोसिएटिभ प्रपर्टीले भन्छ. नाउ एडिटिभ आइडेन्टिटी. ओके, एडिटिभ आइडेन्टिटीले चाहिँ के भन्छ भने एडिटिभ आइडेन्टिटी भनेको आइडेन्टिटी डजन्ट वान्ट्स bring changes in answer. जे छ त्यही रहनु नै आइडेन्टिटी हो. Suppose if A belongs to real number system, there exists a number. If we add them, the answer of that will come itself only. A मा त्यस्तो एउटा रियल नम्बर जोडौं, A plus 0, जसलाई जोड्दा आउने आन्सर चाहिँ A नै रहन्छ. आइडेन्टिटीले चाहिँ चेन्ज हुँदैन, जे छ त्यही रहन्छ. So if we add something with A, still the answer remains same. So here we have added 0 over here, that's why 0 is additive identity of A. So similarly, if we add 0 plus A, then also it gives same answer. Now additive identity पछि the last one is additive inverse. Additive inverse. If A, B belongs to real number system, A plus A inverse, that means A plus minus A gives 0. Inverse means inverse of positive is negative, inverse of multiplication is division. So A plus minus A gives 0. So additive inverse भनेको चाहिँ कुनै पनि रियल नम्बरमा कुनै नम्बर जोड्दा त्यसले दिने आन्सर चाहिँ 0 हुनुपर्छ. So A plus minus A equals 0 is the, here minus A is the additive inverse of A, and if we have minus A here, the additive inverse is A. Let's do multiplicative axioms. Multiplicative axioms. Multiplicative axiom पनि exactly like additive and axioms के हुन्छ, closure, associative, commutative, additive, identity, inverse सबै हुन्छ. So what we have to do over here is multiplicative axiom मा पनि first let's start with closure property. Closure property यसले के भन्छ भने if AB belongs to real number, if A and B belongs to real numbers. A and B दुईवटा real numbers छ भने if we find out the product of A into B, the answer is also belongs to real number only. A र B लाई multiply गर्दा आउने answer पनि real number नै हुन्छ. It is closure property. Now associative. Associative property. If AB belongs to real number, A into B is equal with B into A. If A and B belongs to real number, if we multiply, find out the product of A into B, the answer of the product of A and B must be equal with the product of B into A. It is called associative property. Commutative property. If AB belongs to real number, then A dot B equals B dot A. It is commutative property. When two A and B are real numbers, if we multiply, find out the product of A into B, whose product should be equal with the product of B into A. Now, associative property. Associative property. If A B belongs to R, if we find out A and the product of BC, which must be equal with the product of AB and C, it is called associative property. When we have A, B and C belongs to R, when we have three numbers under real numbers, if we find out the product of first with the product of remaining two, which must be equal with the first product of first two and the third one. That means तीनवटा नम्बरलाई नम्बरमा कुनै एउटा नम्बरले बाँकी दुईवटाको प्रोडक्टसँग मल्टिप्लाई गर्दा आउने आन्सर सेम हुन्छ. Now next, fourth one is multiplicative identity. For every real numbers, for every A belongs to R, there exists a real number. Sorry, for every A belongs to R, there exists one which is also belongs to the real numbers, such that A into 1 equals 1 into A is equal with A. That means, as I have already told you, identity doesn't bring change in answer, and we have a number A. If we multiply with certain number, the answer must be equal with A only. That means there should not be any changes in our answer. कुनै एउटा नम्बरलाई रियल नम्बरमा एक्जिस्ट गर्ने त्यस्तो नम्बरसँग मल्टिप्लाई गरौँ, जोसँग मल्टिप्लाई गर्दा आउने आन्सर चाहिँ त्यही नम्बर नै हुन्छ. So it is multiplicative identity. Now multiplicative inverse, the fifth one. For every A belongs to R, there exists inverse of A into A inverse, whose answer should be 1. That means A into 1 by A is 1. So multiplicative inverse should get answer 1 while finding the product with its inverse. So A into A inverse is 1. Similarly, when we multiply A inverse, the inverse of A inverse is A. If we find the product of them, it also gives 1 only as an answer. So here, in this part, A inverse is the inverse of A, but here, as we have A inverse before, A is the inverse of A inverse. So if we find their product, it gives 1 as an answer. Distributive property. For the real number A, B, C, the product of A and B plus C is equal with the sum of the product of AB plus AC. Distributive property means we are distributing A equally to B and C. So for the real number ABC, कुनै पनि तीनवटा नम्बरमा B plus C को समलाई A ले मल्टिप्लाई गर्दा A र B को मल्टिपल प्लस B र C को मल्टिपल को समसँग इक्वल हुन्छ. We have completed field axiom. Now let's discuss about the order axiom. Order axiom clarifies about the order of the real numbers and satisfies the following conditions. If A is greater than 0 and B is also greater than 0, the product of AB is also greater than 0. The first property. And the second, trichotomy property. Trichotomy property. If A and B be the two real numbers, then there exists only three relations between A and B. If A and B be the two real numbers, there exists only three relations between A and B. Either A is greater than B, or A is less than B, or A is equal with B. Trichotomy, the word tri gives three. That means trichotomy भन्ने बित्तिकै यसले चाहिँ तीनवटा operation, either A is greater than B, or A is less than B, or A is equal with B. It gives three different conditions. Number third, transitivity property. Transitivity property. If A, B and C belongs to real number, then the transitivity property says if A is less than B and B is less than C, this implies A is less than C. Conversely, यदि A B भन्दा सानो र B C भन्दा सानो छ भने A C भन्दा पनि सानो हुन्छ. Now conversely, if A is greater than B and B is greater than C, that implies A is greater than C. If A B भन्दा ठुलो र B C भन्दा ठुलो छ भने A C भन्दा पनि ठुलो हुन्छ. Okay, now number 4. Okay, now addition property. Addition property means if A is greater than C, when A is greater than C, if we add equal parts into both the group, A plus D is greater than C plus D, it's the answer, the symbol will remain same. If we add equal person in both the side, still the sign will remain same. That means A र C, A C भन्दा ठुलो छ भने A मा D जोड्दा आउने आन्सर र C मा D जोड्दा आउने आन्सरमा पनि यो नै ठुलो हुन्छ. It is called addition property. Now number 5, multiplication property. If A is greater than B, if we multiply the equal person into both the sides, the answer, the symbol will remain same. If A is greater than B, A into C is greater than B into C. It is called multiplication property. Now next, density axiom. Density axiom. If A, B belongs to real numbers, there exists a real number C. When A, B belongs to real number, there exists a real number C in between A and B. There exists a real number C which is in between A and C gives such that this C is greater than A but less than B. In between A and B, there exists a real number C which is greater than A but less than B. It is called density axiom. Learners, now we are going to do the representation of a number in a real line. Representation of a number in a real line. So we have rational and irrational number. First of all, let's discuss how to represent rational number in a real line. Rational numbers, you all are very familiar with the representation of rational number in a real line, which we have been doing from the beginning of our studies. Even in elementary class we have done. In rational number, we have 0 in the middle, and then towards the right side all the positive values, and towards the left all the negative values like -2, -3, -4, -5 and so on. So like this way we can represent rational numbers in a real line. Irrational number also can be represented in a number line like rational number. For example, let's suppose here √2 is irrational number. You all know √2 is an irrational number. How to represent it in a number line? Let's draw a number line. Oh, and here is -1, -2, -3, -4. Let's draw a square boxes of 1 unit. Here is 1, here is 1. This is a diagonal of our square. To find out the length of a diagonal, we can use the Pythagorean Theorem, as each angle of square is 90 degrees. This is hypotenuse. H equals b square plus b square. So 1 square plus 1 square, which is 1 plus 1, √2 units. So √2 is the length of this diagonal. Now draw a circle keeping radius √2. Suppose this is radius. Now draw a circle with this radius. यो circle को point चाहिँ real line में जहाँनिर this circle intersect at real line, where in which point it intersect, that point, the value of that point is √2. So real line में circle ले जहाँनिर intersect गर्छ त्यही point लाई नै यो irrational number को value देखाउन सकिन्छ. So √2 is the value of √2 in real line is here, and the value of -√2 in real line is here. Now let's discuss about inequality. Inequality. In any two real numbers, there exist trichotomy relations, that is equal to, less than or greater than, and if the relations are expressed in terms of equals to or less than or greater than, this type of relations are called inequality. So there are various symbols under inequality, like this. It means less than, this greater than, this less or equal to, and this means greater or equal to. Learners, let's talk about the interval. Interval means the set of points between two given points is known as interval. There are different types of interval like open interval, closed interval, left open interval, or right open intervals. We will discuss about 4 different types of intervals with its figure. The first one is open interval. OPEN, open interval. An interval in which the starting and ending point is not contained. So that type of interval is called open interval. That means not containing the endpoints. For example, A, B. For example, here you have A, here you have B, and in between you have this. So an interval in which A and B is not containing. That means beside A and B, the remaining portion, this portion only contain. So this type of interval is called open interval. That's why we have written circle only. So now, number second, closed interval. Closed interval means an interval in which both the endpoints containing an interval containing both the endpoints is called closed interval. For example, here is A, here is B. So contained 2, so both contained, we write like this. So circle only means these endpoints will not be counted, and this means A and B also counted over here. So this portion. So containing A and B is closed interval. So while writing this, the x is greater than A and less than B. That means A and B we don't have to count here, but here we need to count A and A. X is greater or equal with A and lesser equal than B. That means the value of x either can be A, B पनि हुन सक्छ अथवा A र B को बीचमा पर्ने मात्र पनि हुन सक्छ. So containing A and B. But here the value of A and B doesn't lie in this interval. Greater than A and less than B only lies. We have discussed about open and close. Now let's discuss about left open interval. Left open interval. An interval not containing A but it contains B is left open interval. For example, here we have A and here we have B. This left open, that means in left side we should have open and in right side closed. So this type of interval is called left open interval. While writing it in inequalities, A, the x is greater than A but less or equal with B. So it is left open interval. Now right open interval. Right open interval. An interval in which right side B doesn't contain. An interval in which B doesn't lie is called right open interval. Suppose A and B, in between A and B, if here we have closed and here we just have, so this means B does not contain in this interval. So it is called right open interval. A is x is greater or equal with A but less than B. So it is right open interval. B doesn't lie in this interval but the value which is less than B lies over here. But here either A or greater than A. The value of A or greater than A lies in this interval. Learners, we have discussed about 4 different intervals. While showing open intervals, open interval means that doesn't contains both A and B. That was open interval. And in closed interval, an interval containing A and B. A पनि पर्ने, B पनि पर्ने, र A र B को बीचमा भएको पर्ने भनेर चाहिँ हामीले क्लोज इन्टरभललाई डिफाइन गर्यौं. त्यसरी नै लेफ्ट ओपन भनेको लेफ्ट साइड को यो चाहिँ नपर्ने, लेफ्ट साइड को A नपर्ने, बट राइट साइड को B चाहिँ पर्ने. द भ्यालु ग्रेटर देन A भन्दा ठुलो बट लेसर इक्वल विथ B पर्न पनि सक्छ अथवा B भन्दा सानो हुँदा चाहिँ यसलाई चाहिँ लेफ्ट ओपन इन्टरभल भनियो. त्यसैगरी राइट ओपन मिन्स एन इन्टरभल नट कन्टेनिङ B. That means but it contains A. A पर्ने, A भन्दा ठुलो तर b नपर्ने b भन्दा सानो a अथवा a भन्दा ठुलो बट b भन्दा सानो सबै पर्नेलाई चाहिँ के भन्छ त राइट ओपन इन्टरभल यसरी हामीले चारवटा डिफरेन्ट इन्टरभललाई चाहिँ व्याख्या गर्यौं Learners, now let's do absolute value. The definition of absolute value. Let's begin with the definition. Let x denote any real number the absolute value is written by modulus x. This is the symbol of modulus, which is non-negative real number. Non-negative real number defined by modulus of x equals x if x is greater or equal to 0 minus x if x is less than 0. So the value of modulus x is always positive, which we need to understand. For example, if we have minus 2 inside modulus, minus 2 plus 4, as modulus always give positive value, it will change this minus negative 2 into positive and plus 4 as it is, and our answer is 6. Similarly, if we have 4 plus minus 7 inside the modular sign, this 4 we write as it is plus minus 7. If we take out minus 7 from modular sign, it will change it into positive. 4 plus 7 is 11. So from here what we have to understand is the modulus always gives positive value. So I would like to repeat you one more time. When x denote any real number, the absolute value is written by modulus x. This is read as modulus x, which is non-negative real number, that defined by x if x is greater or equal to 0 minus x if x is less than 0. Learners, now let's do some properties of absolute values. Let x be any real numbers, then modulus x is greater or equal with 0, modulus x is greater or equal with x, and modulus x is greater or equal with minus x. Similarly, in third, we have minus modulus x is less or equal to x is less or equal to modulus x. So let's begin with the first proof. Let x belongs to real number if x is greater than 0, modulus x gives modulus x equals x is greater than 0. Okay, if x is less than 0 भयो भने चाहिँ के हुन्छ त भन्दा modulus x को value चाहिँ minus x greater than 0. Okay, for यहाँबाट चाहिँ हामीले what we have to understand from here is for all x belongs to real number, जुन पनि real number x को लागि modulus x is greater or equal with 0. कि त 0 भन्दा ठुलो हुन्छ. Now proof of 2. Modulus x is greater or equal to x and modulus x is greater or equal to minus x. If x is greater or equal to 0, then x is greater or equal to minus x. 0 भन्दा ठुलो छ भने minus x भन्दा पनि ठुलो हुन्छ. And modulus of x equals to x, that means modulus of x is lesser equal with minus x. Again, what we can do over here is if x is lesser equal with 0, यो त x 0 भन्दा ठुलो अथवा बराबर हुँदा अब when x is lesser equal with 0, then minus x is lesser equal with x. But what we have modulus of x is greater or equal to minus x. Therefore, what we can say, modulus of x is greater or equal with x. Proved. Proof of third. minus modulus of x is less or equal to x less or equal to modulus of x. Here modulus of x is greater or equal to x implies x is less or equal to modulus of x. Similarly, again what we can say, modulus of x is greater or equal to minus x implies x is greater or equal to modulus x. यसै लाइन लेखेको x is less or equal to modulus x is less or equal to modulus of x implies x is less or equal to modulus of x. Now by combining these two results, what we can say, minus of modulus x is less or equal to x is less or equal to modulus x. यो प्रुफमा हामीले के बुझ्नु पर्यो भने माइनस मोडुलस अफ एक्स, मोडुलस अफ एक्स इज ग्रेटर इक्वल टु एक्स इम्प्लाइज एक्स चाहिँ मोडुलस एक्स भन्दा सानो अथवा बराबर हो, यसैलाई नै यतापट्टि लेखेको भयो. अगेन मोडुलस एक्स इज ग्रेटर इक्वल टु माइनस एक्स implies x is greater or equal to modulus x. So while combining these two results, what we can say, x चाहिँ minus modulus x भन्दा ठुलो अथवा बराबर but plus modulus x भन्दा चाहिँ सानो हुन्छ. This is what we have to prove in third. Let's begin the proof of this. So we have written for any two real numbers x and y, x modulus of x plus y is less or equal to modulus of x plus modulus of y. This is triangle inequality. It is called triangle inequality as well. Modulus of x minus y is greater or equal to modulus of x minus modulus of y. So let's begin with the first proof. X modulus of x plus y whole square equals x plus y whole square. Let's keep in the a plus b whole square form. A square plus 2xy plus y square. And in place of x square, we can write modulus x square plus 2 times modulus of x into modulus of y plus modulus of y square. Since modulus of x is greater or equal to x and modulus of y is greater or equal than y, which is modulus of x plus modulus of y whole square. So therefore modulus of x plus y whole square equals modulus of x plus modulus of y. Let's begin the second proof. Let x minus y equals to z, then x equals to y plus z and modulus of x equals to y plus z को modulus, which is less or equal with modulus of y plus modulus of z equals modulus of y plus, in place of z we can write x minus y, modulus of x minus y. Hence by transposition we get modulus of x minus y is greater or equal to modulus of x minus modulus of y. This is what we have to do. So I'll repeat one more time. Say let x minus y equals to z, then x equals to y plus z and modulus of x equals modulus of y plus z. Because in place of x we have written y plus z, so we can replace it. Less or equal to, it is less or equal to modulus of y plus modulus of z, which means modulus of y as it is plus in place of z we can replace the value of it x minus y. So hence by transposition we got x minus y, modulus of x minus y is greater or equal to modulus of x minus modulus of y. Let's begin the first proof. For x, y belongs to real numbers, modulus of x, y square equals x, y whole square. That means x square, y square. So modulus of x square into modulus of y square equals which is x square y square gives modulo of x square modulo of y square. Therefore, what we can say, modulo of xy equals modulo of x into modulus of y. Proof of second. For x, y belongs to R, when y is not equal with 0, modulus of x by y whole square equals x by y whole square. Since modulus of x is less or equal to x, equals, this is x square by y square, which is x square is equal with modulus x square and y square is equal with modulus y square, since modulus of x is less or equal to x and modulus of y is also less or equal to y. Therefore, modulus of x by y is equal with modulus of x by modulus of y. Proved. Now let's do an example related with the theorem which we have proved just before. Let x equals to 2, y equals to 3. Verify each of the followings. Modulus of x plus y is less or equal to modulus of x plus modulus of y. Modulus of x minus y is greater or equal to modulus of x minus modulus of y. Modulus of xy equals modulus of x into modulus of y. Modulus of x by y equals modulus of x by modulus of y. So here we have given the condition, the value of x is 2 and y is 3. Let's begin the proof. First one, solution. Proof. The first one, proof. X modulus of x plus y equals modulus of x plus y. Let's keep the value of x and y. 2 plus 3 equals modulus of 5, which gives 5. Now, modulus of x plus modulus of y. Modulus of x means 2 plus y is 3. So, when we take out from the modulus, positive is positive only. 2 plus 3, 5. So, therefore, we got same result from both the part. Therefore, what we can say, modulus of x plus y is modulus of x plus modulus of y. Now, second number, B. Proof of second. In second, we have x minus y at first. Let's replace the value of x and y over here. The value of x is 2 minus the value of y is 3. So, 2 minus 3 is minus 1. Since minus 1 is inside the modulus sign, the result is positive 1. Similarly, modulus of x minus modulus of y equals modulus of x 2 minus modulus of y means 3 equals 2 minus 3, which is minus 1. From here, what we have to understand is this 1 is greater than minus 1. Therefore, x modulus of x minus y is greater or equal with modulus of x minus modulus of y. Now, proof of C. Modulus of xy equals 2 into 3. Modulus of 6 gives 6 only. Modulus of x into modulus of y equals 2 into 3. 2 into 3 is 6. Since the modulus of xy and modulus x into modulus y give same results, we can say, therefore we can say modulus of xy is equal with modulus of x into modulus of y, which is proved. Now, proof of D number. We have given modulus of x by y. Let's find out the value of this at first. 2 by 3, which is 2 by 3. Modulus of plus 2 by 3 gives plus 2 by 3 only. Now next we have modulus of x by modulus of y. Modulus of 2 by modulus of 3. Modulus 2 means 2 and modulus 3 means 3. Since it has same value, we can say modulus of x by y is equal with modulus of x by modulus of y. This is how we have proven all 4 questions. Solve the following inequalities. Now we have 4 different inequalities. Solving this means we should remove all the new numbers and keep only the variables over here. Let's begin with the first one. Solution of first one. X minus 1 is greater than 2. So since we have minus 1 here with x, to remove this minus 1 we should add plus 1 into both sides. So now minus 1 and plus 1 will be cancelled. X is greater than 3. This is how we have to do. Now for B number, x minus 3 is less or equal with 5. So first of all, to remove this 3, we can do plus 3. We can add plus 3 in both the sides. Yeah, minus 3 plus 3 cancel. X is less or equal than 8. Now, number C, minus 1 is less than x minus 2 is less than 3. So, first of all, we should try to remove this 2. To remove this minus 2, we should add plus 2 in all 3. Minus 2 plus 2 less than 3 plus 2. So, minus 1 plus 2, 1 less than x is less than 5. Now, solution of the third one. D number, minus 3 less or equal to 2x minus 1 less or equal to 5. First of all, we should remove that minus 1. To remove minus 1, we need to add plus 1 in all sides. Plus 1 less or equal to 5 plus 1. Or minus 2 less or equal to 2x less or equal to 6. To remove this 2 from x, what we need to do is to divide by 2 in all 3 sides. When we divide by 2, here comes minus 1. Here is x, and if we divide 6 by 2, it gives 3. This is how we have to do. Let's begin with the first solution of first. A union B. A equals x such that x is greater or equal to minus 3 but less than 1. B equals x such that x is greater or equal to minus 2 and less or equal with 4. Now A union B equals x such that minus 3, x is greater or equal with minus 3 and less than 1 union x such that x is greater or equal with 2, minus 2 and less or equal with 4. So A union B means either A or B. That's why x such that x is greater or equal with minus 3 and less or equal with 4, which is x is greater or equal to minus 3 and less or equal to 4. That means minus 3 comma 4. Now one more example. Let A equals to minus 3 1 and B equals to minus 2 4. Perform the indicated operations. A union B, A intersection B, A difference B and B difference A. So we should not forget to see over here. This is closed interval and this is open interval. So solution of first of all, list out A, x such that x is greater or equal than minus 3 and less than 1, and B equals x such that x is greater or equal than minus 2 and less or equal than 4. Now to find it out, A union B equals x such that minus 3 less or equal to x less than 1 union x such that minus 2 x less or greater or equal to minus 2 and less or equal with 4. Now union means either in this or in that. Therefore x such that minus x is greater or equal with minus 3 and less or equal with 4, which means close interval of minus 3 and 4. Now start the solution of this second, A intersection B. Since members of A and B are same, now to find out A intersection B, x such that x is greater or equal than minus 3 or less than 1, intersection x such that x is greater or equal than minus 2 and less or equal than 4. Now, since A intersection B means members which are in A as well as in B, that means only the common members, so that x such that x is greater or equal than minus 2 but less than 1. Means minus 2 comma 1, here is close interval, here is open because here is only the symbol of less than. There is not equal to. So minus 2, close interval minus 2, comma 1, open interval. Now the solution of the third one, A difference B. A, x such that x is greater or equal than minus 3 and less than 1. Difference B, x such that x is greater or equal with minus 2 and less or equal with 4. A difference B means members which are in A, not in B. That means from A we need to remove all the members of B, so that x such that x is, from here we need to remove this minus 2, x such that x is greater or equal than minus 3 but less than minus 2, which gives minus 3 comma minus 2. Now let's do the fourth one, B difference A. B difference A. In B we have x such that x is greater or equal than minus 3 and less than 1. Difference x such that x is greater or equal than minus 2 and less or equal than 4. B difference A means members which are in B. From B we should remove all the members of A. That means x such that 1 is less or equal than x and which is less or equal than 4. X is greater or equal than 4, which gives B difference A means from B we need to remove all the members of A. That means x such that x is greater or equal than 1 but less or equal than 4, which means close interval, since we have equal sign in both 1 comma 4. Let's do few more questions. Write the following without using absolute value sign. We have given 3 different inequalities. We need to write it down without using absolute value sign. Let's begin with the first. Modulus of x is less than 4. That means the value of x is less than minus 4. Greater than minus 4 and less than 4. This is the solution of first one. Now B, x minus 3 is less than 2. Solution of this is the value of x minus 3 is greater or equal than, greater than minus 2 and less than 2. Now let's solve this equation. X minus 3 plus 3, if we add here plus 3, here also we should add plus 3, less than 2 plus 3, or 1 less than x less than 5. Let's do the solution of C. 2x plus 1 is, modulus of 2x plus 1 is less or equal with 3. This means the value of 2x plus 1 is greater or equal to minus 3 but less or equal than 3. Let's solve these equations. 2x plus 1. To remove this plus 1, we write minus 1, but we cannot write only in one. We should write in all 3 sides. So, minus 3 minus 1 is minus 4, less or equal to 2x, less or equal to 2. Now, still we have 2 with x. So, to remove this 2, we should divide by 2 in all 3 sides. Minus 4 by 2, less or equal to 2x by 2 is less or equal to 2 by 2, or minus 2 lesser equal to x is lesser equal to 1. This is what we have to do. This is just the reverse than the previous questions. Before we have written modulus into inequalities. Now we have more inequalities. We need to write down using absolute value sign. Before absolute value sign was given and we have made this type of inequalities. Now we have given inequalities. We need to find out the modulus. So let's do one more example. It is just reverse than the previous one. Previous we have given modulus absolute value sign. We have brought this type of inequalities as an answer. Now we have given this type of inequalities. We need to keep this using absolute value sign. So let's begin this. X less than 7 minus 5 minus 1 is less than x minus 1 is less than 7 minus 1. So here minus 6 is less than x minus 1 is less than 6, which means modulus of x minus 1, which means modulus of x minus 1 is less than 6. For the solution of second questions, minus 3 lesser equal to x lesser equal to minus 1 is our question. So minus 3 plus 2 lesser equal to x plus 2 lesser equal to minus 1 plus 2. Now minus 3 plus 2 is minus 1 lesser equal to x plus 2 is lesser equal to plus 1. So why we have written plus 2 is, here we have minus 3, here we have minus 1. So we should get same numbers in left side negative and right side positive. Then only we can write down the middle term inside the absolute sign. That's why when we write plus 2 we can get minus 1 here and plus 1 on this side. That's why we have done this. Now this is x modulus of x plus 2 is lesser equal with 1. One more example. Solve the following inequalities. Modulus of x plus 2 is less than 4. Modulus of x minus 1 is lesser equal to 2. Modulus of 2x plus 3 is lesser equal to 1. And modulus of x minus 1 is greater than 1. This is very important questions from this chapter. So most of the time this question comes as a long question in your exam. So let's begin with the first. A number x plus 2 is less than 4. It means minus 4 less than x plus 2 is less than 4. Let's solve this equation. Minus 4 minus 2 less than x plus 2 minus 2 less than 4. To remove this plus 2 we have written minus 2 in all. Okay. Minus 6 less than x less than 2. So solve the following inequalities. Let's represent this in a number line, in real number line. In real number line, 0 is at the center. 1, 2, 3, 4, 5, 6. And here minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6. Since it is open interval, we should write circle over here. And the value of x is in here till plus 2. It's minus 6 and 2 are not included. Beside minus 6 and 2, in between whatever values are there, त्यो मात्र include हुने भएको भएर चाहिँ. So we should write this, and this shaded region is the solution. So this means minus 6 less than x less than 2. So excluding minus 6 and 2, all the numbers inside all the numbers of number line is our answer. Solution of B number. Modulus of x minus 1 is lesser equal to 2. This means minus 2 lesser equal to x minus 1. X minus 1 is greater or equal with minus 2 and lesser equal with 2. So while solving this, minus 2 plus 1 is minus 2 plus 1. X minus 1 plus 1. So x minus 1 plus 1 is greater or equal with minus 2 plus 1 and lesser equal than 2 plus 1. So we have written plus 1 in all sides to remove this minus 1. So minus 1 lesser equal to x lesser equal to 3. So to represent this in a number line, So let's draw a number line here. 0, 1, 2, 3, 4. Here -1, -2, -3, -4. So -1 including since the symbol is here greater or equal and lesser equal, -1 and 3 both includes over here. So in containing -1 and 3, this all are the values of x. So this is 1, x greater or equal than 1, -1, x greater or equal than -1 and less or equal than 3. This is the solution of this inequalities. The solution of 3 number 2x plus 3 is less or equal than 1. It means the value of 2x plus 3 is greater or equal than -1 and less or equal than 1. Now while solving these equations, to remove this plus 3, we write -3 in all 3. -3 or -4 less or equal to 2x is less or equal to -2. Still we have 2 with x. So to remove this 2, divide 2 in all sides. 2 less or equal to -2 by 2. Now after we divide all this, -2 less or equal to x is less or equal to -1. To represent this in inequalities, what we do, we draw the number line. Yeah, -1, -1, -2, -3, -4, including -2 and -1, because here we have less or equal sign. So this is 2. So inequalities for x is greater or equal to -2 and less or equal with -1, we do like this. Solution of the D number. If x minus 1 is greater than 1, x minus 1 is greater than 1. If x minus 1 is greater than 0, then x is greater than 1. Sorry, if x minus 1 is greater than 0, x minus 1 is greater than 1. This implies x minus 1 plus 1 is greater than 1 plus 1. So to remove this -1, we have added 1. X is greater than 2. Implies greater than 2 means x, the value of x is 2 to infinity. That's why x belongs to 2 to infinity. This is equation 1. Now, if x minus 1 is less than 0, that means minus x minus 1 is less x minus 1 is less than 0, minus x minus 1 is greater than 1. This implies x minus 1 is less than -1. So what we have to understand over here is x minus 1. To remove this -1, we should write +1, -1 plus 1. So implies x is less than 0. That means the value of x is smaller than 0. This means x belongs to -infinity to 0. This is equation 2. Here we have x belongs to 2 to infinity, and here we have x belongs to -infinity to 0. So from 1 and 2, so while solving 1 and 2, x belongs to -infinity to 0 and x belongs to 2 to infinity. X belongs to -infinity to 0 and x belongs to 2 to infinity. Now to show this in a number line, we can show both in the same number line. Here is 0, 1, 2, 3, 4, 5. Here is -1, -2, -3, -4, -5. The value of x belongs to x is less than 0. So here we have 0. Less than 0 means the value of x is over here. So this means x is less than 0. Now we need to show x for x is greater than 2. So but not 2. Greater than 2 means the value of x is greater than 2 means not 2 but greater than 2. So without including 0 and 2 we need to show, that's why here is x is greater than 2. So this is what we have to do. So here what we have done over here is the value of x is 2. Greater than 2 means it can be 3, 4, 5, 6 till the infinity. So we have shown this arrow. We can continuously extend that arrow, and even this side the value of x is less than 0 means till minus infinity to plus infinity the value of x lies. Using the properties of real numbers, we need to prove that a plus b equals b plus c implies a is equal with c. AC equals bc implies a equals to b. Number C, a is less than b implies a plus c is less than b plus c. Next, D number, a is less than b and c is less than d implies a plus c is less than b plus d. A is greater than b and c is less than 0 implies AC is less than BC. Now the last one, a is greater than b and c is greater than 0 implies a by c is greater than b by c. Since a plus b equals b plus c, so a plus b equals b plus c, to prove this we have b in both the side. If we write minus b, both b will be cancelled, a equals to c. The solution of first one is proved. Now second one, AC equals BC. C, if we multiply C with C inverse, it gives 1. So we can multiply by C inverse in both the sides. AC into C inverse equals BC into C inverse. C into C inverse gives 1. A into 1, which we have already discussed before. B into 1, which gives A is equal with B. The second one is also proved. Now the third one, A is less than B implies B minus A is greater than 0. B plus C minus A plus C equals B plus C minus A minus C while opening the bracket, means B minus A is greater than 0. Therefore, A plus C is less than B plus C. This is the solution of number C. Now D, A is less than B and C is less than D. So solution of number D is A is less than B. A is less than B implies B minus A is greater than 0. Similarly, C is less than D implies D minus C is also greater than 0. Now, by this two, what we can say, B plus D minus A plus C, which means B plus D, open the bracket, minus A minus C. B plus D minus A minus C. We can bring A in front, B minus A plus D minus C. B minus A plus D minus C is greater than 0. Now, what we can say, B minus A plus D minus C is greater than 0. Here, B plus D is greater than A plus C. Therefore, A plus C is less than B plus D. A plus C is less than B plus D, which is also proved. The solution of E number. A is greater than 0 implies A minus B is less than C. A is greater than B means A minus B is greater than C. C is less than 0 implies minus C is greater than 0. Minus C is greater than 0. Minus C into A minus B is greater than 0. Minus C into A minus B. Now minus CA plus C into B, BC is greater than 0. That means BC minus CA is greater than 0 implies BC is greater than CA. I have sent this CA into that side. BC is greater than CA. So what we need to prove? We need to prove BC is greater than AC. Therefore, what we can say? AC is less than BC, or BC is greater than AC, which we wanted to prove over here. F number, A is greater than B. If A is greater than B implies A minus B is greater than 0. That means C is also greater than 0. So A by C minus B by C is also, A by C minus B by C is equal with, C is the LCM, A minus B by C, which is also greater than 0. This means we can write down A by C minus B by C in place of this. A by C is greater than B by C, which we wanted to prove. Now, the last question for this chapter. If x belongs to real number and a be any positive real number, then modulus of x is less than a implies minus x is greater than minus a and less than a, and conversely. So let's begin the proof. For all x belongs to R, modulus of x is greater or equal to x. Here, given modulus of x is less than a, which means x is less or equal to modulus x is less than a, implies x is less than a. This is equation 1. Now again, for all x belongs to R, modulus of x is less or equal to minus x, given modulus of x is less than a, minus x is less or equal with modulus x is less than a, which implies minus x is less than a. This means x is greater than minus a. This is equation 2. Now, combining equation 1 and 2, combining equation 1 and 2, minus a is less than x is less than a. Conversely, that is, if minus a is less than x is less than a, then modulus of x is less than a. Firstly, x is less than a. If x is greater or equal than 0, then modulus of x is equal with x. Therefore, modulus of x is equal with x, which is less than a. So again, what we can do over here is minus a is less than x. That implies x is greater than minus a. Means minus x is less than a. But for x is less than 0, modulus of x is equal with minus x. That means modulus of x is minus x less than a, which is second. So modulus of x is less than a. So converse part is also over. Now in summary, let's see, for all real number x belongs to R, modulus of x is greater or equal to x, x is less than a, x is less or equal with modulus of x is less than a. That means x is less than a. For all real numbers x belongs to R, for all x belongs to R, modulus of x is greater or equal than minus x. But we have given modulus of x is less than a. Less than a means the modulus of x, value of modulus of x is less or equal, greater or equal than minus x less than a. So minus x less than a, x is greater than minus a. So while combining this equation 1 and 2, minus a is less than x is greater than minus a but less than a. So conversely we can prove the converse part as well. to discuss about the topic logic. So, a process by which a conclusion of the given argument can be obtained with a sound reasoning is known as a logic. Logic can be either true or false. So, after logic, statements. Statements. A sentence which declares something which is either true or false but not both is known as a statement. There are two different kinds of a statement. One is simple statement and another one is compound. A sentence which declares only one thing is known as a simple statement, but compound statement means combination of two or more than two. Combination of two or more than two known as a compound statements. So we have two different types of statements. One is simple and another one is compound. Simple means only. Simple means a sentence which declares something only. Simple means which declares only one thing, and compound means two or more than two things. There are various connective symbols such as some not, and, or, if, then, or if and only if. So let's represent it in a table. So connectives, CONNECTIVES, connectives. Here we write symbols, and here at the last, compound statements formed by connectives. Compound statements formed by connectives. Connectives. There are different types of connectives like not. This is the symbol for this. It means negation. Negate, negation. And similarly, we have a symbol and. This means and it is called conjunction. CONJUCTN, conjunction. It is read as and. For the conjunction, we read as and another one is or. This is the symbol for this. It is called disjunction. DIS, disjunction. Similarly, we have if or then. If or then means conditional. So either this or we write this. It is called conditional sentence. Conditional statement. And the last one we have if and only if. That is if and only if. For that we write IFF. If and only if means both the side, this or this. It is called biconditional. Biconditional. And these symbols read as negation is read as not, conjunction this symbol is read as and, disjunction this symbol is read as or, conditional this symbol is read as if, then, and biconditional this symbol is read as if and only if. Now let's discuss how to make a truth table of compound statement by using connectives. First one is negation. Negation. If P denoted a statement, then negation of statement P is denoted by negation P. So that means negation, this is the symbol negation P. And we have logic for this. To negate the statement, we use this symbol to negate the statement. So for this, we can make a truth table. Truth table P. If in P we have either true or false, the statement can be either true or false. And the negation P means if here is true, negation of true is false and negation of false is true. So this is what the truth table for negation is. If here is true, negation P means false. If here is false, negation P means true. Now conjunction. If conjunction, C-O-N, conjunction means if any two statements combining by using the word and, then the compound statement is called conjunction. When P and Q are two statements, then the form compound statement is denoted by P and Q and is read as P and Q. So logic of this is the conjunction of two statement is true when both the statements are true. If any one is false, then the result is false. The table of this is P, Q. So you might have questions as true, true, false, true, true, false, false, true, false, true, false. You might have questions why I have written TTFF and TFTF. This means two statements are the two statements can be either both true or one true, one false, or first false and second true, or both false. We have only these four conditions when we have two conditions. Both can be true, both can be false, first true, second false, or first false and the second is true. So as I have already told you, this is the symbol of and. Conjunction means P and Q. So in conjunctions, as I have already told you, when both the statements are true, the result is true. If at least one statement is false, then result is false. Here we have one false, so false. Here also we have one false, false. This is also false. Only if both are true, then only the result is true, otherwise false. This is conjunction. Now disjunction. The symbol is this, means or. Okay. If any two statements are combined by word or, then the statement formed is called disjunction. If P and Q are two statements, then the compound statement formed by disjunction is defined by P or Q, and it's read as P or Q, P or Q. So its logic is the disjunction of two statements is true if any one or both statements are true, and false if both the statements are false. That means एउटा true भयो भने true भयो अथवा दुवै true भयो भने true भयो, but दुईटै false भयो भने चाहिँ the result will be false. Let's draw the truth table for this. I have already told you why I have written TT and FF over here. TF, TF. Two statements can be both true, first true, second false, or first false, second true, or both false. Now here we need to find it out P or Q. So before we find P or Q, I will remind you one more time. If one statement is true, result is true. If both the statements are true, result true. But if both are false, result false. That means in both false, the result will be false, remaining all true. This is what we have to do in disjunction. This is the relation of or. C-O-N, conditional, P then Q. It is read as P then Q. Conditional. If P and Q are true statements, then conditional of statement is denoted by P tends to Q and it is read as P then Q. So its logic is, in this case, one is called hypothesis, first one is called hypothesis and the second one is called the conclusion. if our hypothesis is true and conclusion is also true, the result is true. But sometimes when our hypothesis is false but conclusion is true, then the answer is true. So this is what we have to do over here. Let's see the truth value of this P, Q, T, T, F, F, T, F, T, F. So condition P then Q. If this is hypothesis and this is conclusion, hypothesis is true, conclusion is true, the answer is true. Hypothesis is true, but the conclusion is false, so the answer is false. Hypothesis is false, but conclusion is true, gives true, and it is false. So conditional means we have two different conditions over here. It is hypothesis and it is the conclusion. Though our hypothesis is wrong, if our conclusion comes true, then the answer is true, otherwise false. This is what we have to understand here in conditional. Now conditional, written as P tends to Q, and it is read as P then Q. So if P and Q are the two statements, then conditional of a statement is denoted by P tends to Q and it is read as P then Q. Its logic is the conditional of statement is false if hypothesis is true and conclusion is false. Otherwise, all are true. So let's draw the table for this P tends to Q. T, T, F, F, T, F, T, T. If our hypothesis is, it is also true, so the result is true. Hypothesis is true, it is false. Conclusion is false, the result is false. Hypothesis is false, conclusion is true, the result is true. Hypothesis is false and conclusion is also false, and the result is true. That means the result is false only if the hypothesis is true and the conclusion is false. There are three different types of conditional statements, such as converse, inverse, and contrapositive. So converse, if P tends to Q is conditional, then converse of P tends to Q is Q tends to P. That means converse of P then Q is Q then P. The truth table of converse of P then Q is Q then P. The truth table for converse is P, Q, P then Q, Q then P. Okay. T, T, F, F, true, false, true, false. As I have already told you, P then Q. In P then Q, only when the hypothesis is true, false, and conclusion is true, then the result is false. In other case, all are true. If hypothesis is true but conclusion is false, then the result is false. In other case, all are true. Hypothesis true, conclusion is false. F. In other case, all true. Similarly, Q then P. We should start to see from Q. If hypothesis is true and conclusion is false, it is false, remaining all true. This is truth table for converse. Okay. Similarly, we can draw the truth table of inverse and contrapositive as well.